Hi everyone, thanks for dropping in. So in this talk I'm going to be taking a look at the Northern City Shift. So that's that clockwise rotation of mid and low English monophthongs in some parts of the United States. And the sort of point about this that I want to flag really early on is that, the Northern City Shift is a chain shift. So, early changes led to later changes, led to later changes. Usually we think of that as movement of the trap or the lot vowel first, and then the others following it in order. So as far as spread of the Northern City Shift, usually associated with the sort of inland north around the Great Lakes. And then it's also in St. Louis, and so that's the, in this map from the Atlas of North American English, basically speakers with the Northern City Shift features are in blue, and so we can see that one oddball to the southwest that isn't really near the Great Lakes at all. And so St. Louis has been sort of interesting as this case of sort of dialect breach where inland north features have made it into the Midland along the I-50 corridor between Chicago and St. Louis. But a decent number of studies in the last couple decades have done a pretty good job of finding features of the Northern City Shift in St. Louis. Obviously, we need to hedge basically just like every other city that we seem to be studying in the last few years that when we say Northern City Shift features are attested in Greater St. Louis, we're really meaning among certain age groups because especially trap raising and lot fronting seem to be retreating in apparent time. So it's one thing to say that St. Louis has Northern City Shift features, but there's some oddities compared to some of the sort of core Great Lakes cities with how St. Louis seems to have it. So one of these points is just that in the Atlas of North American English, only one speaker from St. Louis actually meets all of the Atlas's criteria for the Northern City Shift. And so we would think because, some of the earlier features are trap and lot, that, that probably just means that the other St. Louis speakers, have some of these earlier features, they just don't have all of the features yet. But that doesn't actually seem to be the case. The plurality features in the Atlas are actually dress backing and strut backing among the St. Louisans. And they're actually a bit more inconsistent in whether they actually are engaging in lot fronting and trap raising. And so for that reason, basically, Labov has suggested that the Northern City Shift isn't actually a chain shift in St. Louis. And instead what happened is that individual features came to St. Louis, probably from Chicago, but diffusing among the adult population and then sort of getting picked up by children thereafter. So this as a argument, I think does make sense based on the data that's available, but at the same time, it's primarily based on interviewed, the data from the Atlas of North American English. There might be a little bit more in Labov's paper, but we're mostly dealing with the 4 St. Louis speakers in the Atlas. And so in this talk, what I want to do is basically just say, okay, let's see what we actually see in a larger data set and see sort of more specifically whether there's any evidence of the Northern City Shift features having any structural relation in Greater St. Louis. So the way I'm going to go about doing this, I'm going to first tell you about the data set I'll be using. Then once we've sort of established that, then I'll think about how to actually approach this question of whether there's a structural relation. And then based on that approach, we'll see what actually happens. So the data that I'll be using are sociolinguistic interviews with 48 white middle-class women. They're born between 1935 and 1995. They've been sampled from the city of St. Louis itself and then an inner ring and an outer ring suburb. So I had been using these speakers to take a look at suburbanization and language variation and change. But for today, we're just going to combine them all together and say, okay, these are all people from Greater St. Louis. So I will account for age and place as we go here, but for the most part, since we're looking at this question of structural relation, we don't really expect social factors to be doing much, so we're just going to combine them all together here. So from these sociolinguistic interviews, I extracted tokens of trap, lot, thought, dress, and strut. And for these vowels, for the most part, we're going to do single point measurement using the 40 at 40% of the vowel duration. The exception is going to be trap. We're going to use 20% for that, and that's because Northern City Shift trap often tends to be diphthongized, and we want to make sure that we're actually measuring the raised and fronted onset and not actually the centralized off-glide. So I've normalized this data a little bit differently than sort of some of the more typical normalization procedures we use nowadays. And the reason for that is that since we're interested in basically the relative position of these vowels with respect to one another, we want to make sure that any differences in their vowel shapes or in the space of in the shape of their vowel spaces based on other vowels doing things, that we want to make sure that that doesn't influence how the normalization procedure is treating the Northern City Shift vowels. So I'm going to basically use a modified version of Gerstmann's 1968 method, and in the abstract what that's doing is treating the vowel space as a rectangle, getting the endpoints of that, and then rescaling the vowels for their relative position on that rectangle. And hopefully what that'll end up doing is not skewing the vowel space too much if people have differently shaped vowel spaces. So Gerstmann's formula is given on the slide here. I've modified it in a few ways. The one non-cosmetic change is that instead of using the extreme observations for minimum and maximum, I'm using means of a speaker's extreme vowels. And so effectively what that means is that for F1, the minimum vowel that we're going to be using is fleece, and the maximum is going to have to be lot. I know that that's sort of annoying that we have to use a Northern City Shift vowel to normalize our data, but it doesn't make much sense to me to use a diphthong, and we really don't have any other vowels in the low space to use as an extreme, so we're going to have to use lot here. For F2, the maximum is again easy. It's going to be fleece again. The minimum is a bit trickier. So obviously St. Louis has some lot fronting because of the NCS, but it also does seem to have some goose and goat and mouth fronting. And so basically St. Louisans just don't seem to believe in back vowels. And so to get a minimum F2 for vowels, what seems to make sense to me is to just say, okay, let's let co-articulation with the following liquid represent as far back as they're willing to go in F2. So we're going to use the average of force and pull for that. So here's what this looks like. Apologies for not having the high back vowels in this vowel plot here, but basically what we can see is that if we had been using the extreme observations, we would have expected to see this scale between 0 and 1, and because we're using vowel means, it goes a little bit further on both ends. But basically what we've got is that in F1, we're going from about minus 0.25 for the bulk of the tokens to about 1.5. And that's where 0 is going to be higher, 1 is going to be a lower vowel. And then for F2, we've got, again, looks like the bulk of the tokens are probably at about from minus 0.5 to about 1. And again, so closer to 0 is going to be a fronter vowel, and positive values towards 1 are going to be backer vowels. So even just looking at this chart, we do see that these, so this is all the St. Louisans combined together, and we can see that they are a bit NCSy. So we've got, lot does seem to be this sort of more central looking point. Trap is well higher than lot, so trap raising seems to be in effect here. And we can also see that strut seems to be at least as back as and possibly backer than lot. So those three vowels do seem pretty NCSy, sort of if we're just looking in sort of this global view of it. Okay, so that's the data we're using. So how to actually go about looking for a structural relation? Well, the way I'm going to approach this is basically to say, okay, a change shift is effectively an implicational hierarchy, because if you have a later stage of a change shift, that implies that you have the early stage because there's that temporal link between all of these features. And so then the question is basically just how to demonstrate that there is a implicational hierarchy going on. So one approach might be to use the criteria that the Atlas of North American English uses, that basically if we have criteria for saying whether, trap is raised, lot is fronted, dress is backed, strut is backed, we could, use those criteria and say, okay, we expect to see that if you meet the UD criteria, that you meet the AE1 criteria. But the issue with that, well, there's two issues. One is that 3 of those criteria are depending on the relative position of 2 vowels. And so what it means to actually meet one of those criteria if we don't actually know how linked these features are is a bit unclear. The other issue is that 3 of the criteria are relying on specific values from the Atlas data, and so we would need to convert those to other scales. And the Atlas, the data reported in the Atlas is not exactly ideal for translating it into the normalization method I've done. So it's probably not ideal to use these criteria, actually. Just as a side note, I have tried it. I've done a few different approaches to it. Basically, what tends to happen is, regardless of exactly how we approach this, is that the majority of the speakers meet the ED and UD criteria, so the dress backing and strut backing, and far fewer are meeting the criteria for trap raising and lat fronting. And so that's basically what the Atlas had found among its 4 speakers. We see that among 48 speakers as well. It's the same sort of pattern there. So if we're not going to use the criteria to look at this implicational hierarchy, the way I want to think about this is just to say, okay, well, what do 2 stages of a chain shift look like if we plot them against each other? And we'd probably expect to see something like this, where, so I've put the leading feature on the x-axis, following feature on the y-axis, and we basically are going to go from less shifted to more shifted, left to right, or down to up. So basically what we'd expect to see is that when the leading feature is not shifted very much, it hasn't triggered the next stage, so we're just going to sort of see this flat line as it increases in shiftedness for a while. And then at some point, that next stage is going to get triggered, and so we'll start seeing that as the leading feature keeps increasing, that the following feature is also going to increase as well. And so basically what this means is that we should be able to draw a line between, those 2 points. There's going to be a positive correlation. It's not going to be a perfect positive correlation, and not just because it's really a flat horizontal line meeting a sloped line, but also because we'd also expect there to be a lot of messiness in the data towards the next stage getting triggered, where you have perhaps older speakers who have a pretty shifted leading feature but haven't actually adopted the following feature, perhaps younger speakers who retreated from the following feature but kept the leading feature, that sort of thing. We might also expect to see some messiness in the sort of left-hand corner here, where perhaps there's retreat from the leading feature, but that the following feature hasn't been retreated from as much. So this will be a bit messy, but basically a good first pass, I think, at seeing if there's a structural relation between the vowels is just to say, are they correlated with each other positively? And so I'm going to just take this approach of doing linear regression. We're just going to take speaker means of one NCS feature, we're going to regress it against speaker means of the other NCS feature. And basically we're going to be interpreting a significant positive effect of vowel as a structural relation. Ideally, it's going to have a reasonably high R-squared, but that's going to depend on, how, messy that data actually is. And then we're going to interpret non-significance or significant negative effects then as no relation, because that isn't the kind of relation we're looking for. So like I mentioned earlier, I'm going to throw in age and location as additional factors, but they really don't amount to anything here. So again, this is a good first pass, I think. There is some caution. We're doing a lot of regression analyses, so ought to take that into account. And then also, that especially non-significance, I think, can be showing up due for other reasons. So it could be because there's so much messiness in, a feature reversing or a feature being slow to be taken up after the leading feature. And so it'll be helpful to actually look at these scatter plots of these visually as well. So basically, here's what happens when we do these 10 linear regressions. We find that 3 vowels, so that's dress and strut and thought, actually have positive correlations with each other. And so I've marked those in blue. The darker the shade, the higher the R-squared value. And the other vowels, so trap and lot, don't seem to correlate positively with these in the way that we would expect if there is sort of a structural relation between them. And trap actually doesn't really seem to correlate with anything at all. Lot does this weird negative correlation, but again, it's only positive correlations we're looking for, so neither of those in that sense are correlated with dress and strut and thought in the way we'd expect for a structural relation. So what these actually look like visually, here is on the left we've got dress versus strut, on the right we've got dress versus thought. And basically, this looks more or less like that chart that I'd drawn out, where when dress is fronter than about 0.2 here, strut's not really doing anything. When dress is backer than 0.2, the further back it gets, the further back strut gets. And so this basically looks exactly like we would have expected if dress backing is leading strut backing. And so for thought, the correlation's a bit messier. The R squared is lower, but it does mostly look like the same sort of thing. Dress backing seems to be leading thought lowering. Now, I'd said trap doesn't really seem to correlate with anything. This is sort of why here is a plot of trap versus lot. I do think this is in part because trap raising in particular is retreating among younger speakers, and I think trap and lot actually might be one of these cases where non-significance is sort of obscured by retreat going on. And sort of here's what I mean by that. If we look at this plot of trap versus lot here, we kind of see that once trap gets raised past this maybe 0.8 threshold, lot starts really decreasing in value. So that would be lot fronting going on. So it does seem kind of like we've got that correlation of trap leading lot. We also have this cluster of 6 speakers then in the sort of mid upper left that make this not look like anything at all. But what we can see by just looking at this size of these dots corresponding to age is that 5 of that cluster of 6 is actually pretty young speakers who would be participating in the retreat from trap raising. So what this could be is that trap did lead lot structurally, but the retreat from trap raising has obscured that relation perhaps. So as far as what we were finding then, basically it looks like there are 3 NCS features that are structurally linked. Those are dress and strut and thought. And looking at these visually, it really looks like dress led the others in adoption. And so, this combined with that sort of hedge about the A&E criteria I had mentioned earlier, basically it seems like St. Louis is indeed stronger in dress and strut. So having those vowels back than in having other NCS features. So we do in that sense replicate what's been seen before with a much smaller sample. But I want to point out that we're actually seeing clockwise rotation of these vowels here if dress backing is what's leading these other 2 vowels in participating in these sort of features. At the same time, the reversal of trap does seem to make things messy. I do think it may have originally been weakly linked to lot. You are welcome to please tell me if you think in the Q&A that I'm just squinting too hard at this and making something out of nothing. But the point here is just that if trap did lead lot, it would have been leading that still is a clockwise rotation. And regardless of whether those 2 vowels are linked to each other or not, both of them seem to be behaving separately from dress and strut and thought. Okay, so what does that mean for St. Louis and the NCS? Well, I think just right off the bat, St. Louis definitely implemented the NCS differently from the sort of core Great Lakes cities. But at the same time, I think it's still important to point out that it really does look like St. Louis has a chain shift. So St. Louis didn't adopt every feature, individually through borrowing. Really, probably only 2 or 3, depending on how we think of that trap-lot relation. So if trap and lot are uncorrelated, 3 features. If trap led lot, 2 features were going to be borrowed. And so that's dress, trap, and possibly lot. Strut and thought, so strut backing, thought lowering, those came to St. Louis through chain shifting. So once dress moved, those 2 followed. And perhaps lot also is being counted here, that lot fronting came about through chain shifting as well. And because we're seeing clockwise rotation going on, sort of stemming from dress backing here, I think that's sort of an interesting point that we should consider about the Northern City shift and how it has to do with this clockwise rotation, because there's been some debate over whether movement of trap or movement of lot is what instigated the Northern City shift. And part of the trickiness is that depending on which city you look at, both look like they could have led it. And so what's interesting here is that we still see clockwise rotation of mid-vowels in St. Louis, but it definitely did not stem from trap and lot moving. So I want to offer this sort of speculative thought that perhaps the NCS, rather than thinking of it as sort of this specific set of changes happening in a specific order, perhaps we think of it as that, it's this robust phonological outcome of movement of a mid or low vowel that has triggered a clockwise rotation of the vowel space. And so in that sense, trap can instigate it, lot can instigate it, dress can instigate it. what's, I think, useful about thinking about it this way is it does sort of resolve that debate over trap and lot because it sort of turns it into a yes and situation. But I think it might offer some insight into how it was able to spread so rapidly across the inland north as well, because, if many different vowels could trigger the NCS, then essentially it doesn't need to be the same vowel being, spreading from city to city. It could be any of those vowels spreading from city to city, and that might help in speeding that process along. Now, I know this is a bit speculative, and so I'd love to discuss it more in the Q&A, but even if you're not quite buying that last point, I think we can reach two conclusions from this study. One is that St. Louis's NCS implementation really is different from the other core cities, but that doesn't mean it doesn't have a change shift. It does, at least in part, have this structured change shift going on. So here are some references if you want to pause and look at them. Otherwise, thanks very much for listening, and I'm looking forward to talking to you more about this in the Q&A.